Now you're ready for your first flight. This lesson will introduce you to all of the systems in the Longbow's pilot cockpit. First, I will show you a system, then I will give you control of the aircraft and allow you to experiment with that system. Let's start with the Integrated Helmet and Display Sighting System, or IHADS. The IHADS displays information through a monocle covering your right eye. The system is designed so that the symbology appears to be hanging in space right in the center of your field of view. The IHADS has 4 modes, each designed to show you different flight information. The modes are hover, bob up, transition, and cruise. You change modes by hitting the End key. Hover is the simplest of modes. It displays basic flight information. All other modes build upon hover mode. Bob up is used for what its name implies, bobbing up over a hill. This mode adds an octagonal box that indicates your aircraft's overhead position relative to a spot on the ground. Transition mode is where you will spend most of your time. Its distinguishing characteristic is the attitude indicator, which only appears in this mode. Cruise mode looks and acts like the heads-up display of a jet fighter. It is distinguished by the pitch ladder and roll indicator. Across the top of your field of view is the compass. It displays your current magnetic heading, the command heading to the next waypoint, the direction in which the TAD sensor is pointing, and the scanning direction of the Longbow fire control radar. Okay, you now have control of the aircraft. To start the engine, press the R key. Increase your torque until the aircraft begins climbing. Climbing torque for takeoff is 90%. To increase torque, use the plus key. Do this until you start climbing. Now, take control of the aircraft. To yaw the aircraft left, use the left bracket key. To yaw right, use the right bracket key. Watch how your heading changes, as well as the position of the command heading and the TAD sensor. When you are done, hit the escape key. I have the aircraft. Good job. Over on the right side of the field of view is the altitude ladder. This ladder displays the radar altitude in feet. This is your distance above the ground. This bar gives you a quick impression of your distance above the ground. When you're on the ground, the bar is at the bottom of its range. As you gain altitude, the bar rises. The bar is only useful up to 200 feet. After that, it disappears. This is your real altitude above sea level. Not as important as your distance from the ground, this information is used when flying non-combat missions or when your altitude exceeds 200 feet. The arrow next to the altitude indicator is the vertical speed indicator. When it's centered, you're hovering in the air, neither gaining or losing altitude. The scale for the VSI is plus or minus 1,000 feet per minute. Again, I will give you control of the aircraft. To increase torque, use the plus key. To decrease torque, use the minus key. Have the aircraft. On the left side of the IHADS display is the airspeed indicator. It shows the aircraft's forward speed in knots. Across the center of the display is the attitude indicator. This line is like an artificial horizon and gives you an indication of the aircraft's pitch and roll.
Triple A detected.
In the bottom left corner is the waypoint indicator. It shows you the next waypoint number, the distance to it in kilometers, and the time required to reach the waypoint at your current airspeed. In the lower midsection of the display is the slip ball. It shows the aircraft's yaw in relation to the direction that it is traveling. When you can turn and keep the ball in the center, you are making coordinated turns. The flight path vector gives you a real-world representation of the flight path of the aircraft. If the flight path vector is over the ground, it means you're going to crash, and you might want to add collective. Emanating from the center of the display are the velocity vector and acceleration cue. The velocity vector shows your direction and speed relative to the current position of the aircraft. It is like an overhead arrow pointing to where you are going. The acceleration cue shows the lateral acceleration in the same scale as the velocity vector. In the upper left of the display is the torque percentage. This number represents the average torque of both engines in relation to the maximum torque possible. Since the engine can produce more than maximum torque, this number can exceed 100%. Now, take control of the aircraft. Work all of the controls and watch how the displays react to your control inputs. When you are done, hit the escape key. You have the aircraft. Okay, I have the aircraft. Another important set of information displayed on the iHads is data from the various sensors in the aircraft. The cross in the middle of the sensor represents the center of the field of view, or your line of sight directly ahead.
Triple bearing detected.
When aiming weapons or sensors, it is important to keep this symbol on the target. The box in the bottom center of the display is the field of regard box, or FOR. The box represents the total area that the sensors can see, or 220 degrees across. The small box in the field of regard represents the TAD's field of view. The dashed line represents the direction of the fire control radar. To the left of the FOR box is the high action display, or TAD, for the sensor system. The top number is the computer range to the target currently engaged by either the TADS or FCR. The bottom text is used to relay site status information. The iHads is also used to display information useful in deploying the aircraft's weapon systems. Every weapon has its own symbology, so pay attention. On the top and to the right of the FOR box is the high action display for the weapon system. The text across the top of the FOR is the weapon inhibit field. Messages here inform the crew as to why the current weapon cannot be fired, usually due to a bad angle, damaged system, or out-of-range target. The top right text field tells the crew what weapon is currently selected. MSL stands for the Hellfire missile. RKT stands for rocket, and ATA stands for air-to-air missiles, representing the Stinger missiles on board the Longbow. The symbology for the Hellfires is used to guide the pilot to an optimal firing position. A box will appear on the iHads. If you are in LOBL mode, the box will be small, representing the tighter firing constraints. If you are in LOAL mode, the box is much larger. If the box is dashed, the missile cannot see the target. Turn your aircraft so that the missile box is on the target. If the box is solid, you can fire. The ATA symbology is quite simple. When the ATA system is activated, two concentric circles appear. The innermost circle is the aiming reticule. You simply steer the aircraft until the circle is on the target. When you get a lock, the innermost circle turns solid and you hear a missile lock tone. The outermost circle represents the missile constraints. If the missile is within firing constraints, such as the correct airspeed or pitch angle, the outer circle turns solid. The two multifunction displays, or MFDs, in the cockpit give the pilot a wide choice of which data can be displayed. Each display can be separately set to various pages that show information about the aircraft, targets, or the entire battlefield. Both MFDs can be controlled separately to display any screen. To cycle through the displays on the left MFD, press the... To cycle through the displays on the right MFD, press the... This is the weapon page. It uses an aircraft symbol to show the weapon load and how many weapons remain of each type. Text boxes across the top indicate the status of the sensor package. On the top of the page is the master arm indicator. When this says arm, the weapon system is ready to fire. To arm the weapons, use the... To the upper left of the aircraft symbol is the sight indicator, which shows what system is being used to acquire and designate targets. The available sensors are the TADS and the FCR. To switch between the sights, use the missile launch mode indicator is in the middle left of the display. It can be either LOBL for lock on before launch mode or LOAL for lock on after launch mode. To toggle missile launch modes, use these modes will be discussed in detail during weapons training. Range can be provided by either the laser rangefinder in the TADS or by the FCR. When you switch the sensor package, the range indicator in the middle right of the weapon page changes accordingly. The weapons on the aircraft symbol gives the pilot a quick indication of what weapons are available. The gun counter in the middle of the aircraft tells how many rounds are left in the chain gun. The boxes representing the rocket pods tell how many rockets are left. And each Hellfire missile is represented by its own missile symbol. The selected weapon system displays as a reversed image. And finally, we reach countermeasures. The chaff and flare indicators near the bottom of the aircraft symbol show how many countermeasures remain of each type. The Tactical Situation Display, or TSD, is the most important MFD. It displays all relevant battlefield information to the air crew, including waypoints, FCR targets, known air defense threats, and enemy lines. With the aircraft in the bottom center of the display, the pilot gets a clear view of what lies ahead. To display all this information in a legible format, the TSD has several cursor controls for changing scale, designating targets, and decluttering the symbology to show only what's needed. The mission waypoints appear on this display with route information, waypoint numbers, and relative headings evident. The current waypoint is highlighted. The window in the bottom left echoes information in the waypoint section of the IHABs. The enemy lines are also displayed. This allows the pilot to know when the aircraft crosses over into enemy-held territory. The circles represent air defense threats and their ranges. The numbers in the middle of the circle show the type of threat. For example, threat number 23 represents a ZSU-23 anti-aircraft gun. This allows the pilot to avoid known and detected air defense sites. The TSD also shows the sensor footprint for the fire control radar. The current line of sight of the TADS is also shown. This gives the pilot a quick indication of where his targets are relative to the real world. When the TSD has enemies in range, the target blips turn into symbols. These graphics represent target types that have been identified by the FCR system. The designated target has a bright diamond symbol around it. The rectangular areas around the targets are called priority fire zones. These zones allow the crew to assign different target areas to different aircraft. The crew draws lines around the targets, and the information is passed to all participants by the Improved Data Modem, or IDM. The radar page shows raw returns from the FCR. It displays targets but doesn't identify them by type. The radar can be set to two modes. The ground mode shows all ground targets within a 90-degree arc across the front of the aircraft. The air mode shows all air targets in a full 360-degree sweep around the aircraft. The Range for the FCR is set using the ranges are 5, 10, 25, and 50 kilometers. The TADS page is used to show various views of the target acquisition display system. This helps the crew use the sensor package to sweep an area, then identify targets and lock them up for engagement. The various cameras of the TADS package can be panned and zoomed to any location. By default, the TADS points to the current target of the weapon system. To zoom in on the target, use the to zoom out, press the to move the camera, use the cursor control in the MFD. The current zoom level is displayed in the upper left corner of the MFD. The camera's position relative to the aircraft is displayed in the field of regard at the bottom of the MFD. The TADS can use any one of 3 cameras. The direct optics, the direct TV, and the forward-looking infrared cameras are used automatically as you zoom into the target. The symbol of the current camera is displayed in the upper left. The Aircraft Survival Equipment, or ASE, is a collection of components that help the aircraft deal with anti-aircraft threats. This includes the passive radar warning receiver, the radio frequency interferometer, the radar jammer, the IR jammer, and the chaff dispenser. The ASE display gives a 360-degree view of the area around your aircraft. The RWR and the RFI determine the location and type of threats and displays them relative to your position. The threat radius appears as a circle. Information about the threat is conveyed through its symbology on the ASE page. The threat symbol denotes whether it is an anti-aircraft gun or a surface-to-air missile. The number next to the symbol identifies the specific weapon system. For example, a SAM symbol with the number 11 next to it denotes a Russian SA-11 SAM site. Other information displayed on the ASE page includes the status of the ASE equipment, the number of chaff pods, and the radar jammer and IR jammer status display in boxes around the aircraft graphic. When the aircraft is engaged by a threat, the ASE page automatically appears in the right cockpit MFD to ensure that the crew is aware of the situation. Another function of the ASE is to tell the pilot about threats via a voice message system. When the aircraft is engaged by a threat, the pilot receives a voice message on the intercom. This system identifies the threat and gives its location relative to the aircraft. Across the top of the cockpit is the up-front controller. It is used to display engine and radio information. You switch the up-front controller and cycle through its modes using the in-engine mode. The up-front controller displays information about the 2 engines, including their torque, operating temperature, and RPM. In the event of total electronics failure in the cockpit, there are also secondary analog gauges that measure your flight parameters. These include an airspeed indicator, an altimeter, and an artificial horizon. All of these displays can be individually configured, or you can use the master modes to automatically switch all relevant avionics to the appropriate mode. There are 4 master modes: navigation, air-to-air, direct fire, and indirect fire. To change master modes, hit the watch how the IHADS mode and the MFDs change. To cycle through all the modes, toggle the master mode key 4 times. Now you know the flight instruments and avionics. In your next mission, you will learn basic flight maneuvers.